If you look at the distances between the planets, Mercury, Venus, Earth, Mars, Jupiter, there's a huge gap between Mars and Jupiter.
Okay.
And people are saying, there should be a planet there.
Right.
Let's look.
Yeah.
This is in the 1700s. Let's look. There's got to be a planet there. And we discovered a planet there. We discovered planet Sirius. And then Pallas and Vesta and Juno, the first 4 planets discovered in the asteroid belt. If you look up in 1805 textbooks for how many planets there were in the solar system, it was Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Pallas, Vesta, Juno, and the 4th one. I forgot what. So they were counted as planets until we said, wait a minute, they're all in the same place and they're kind of different and they're really small. They're kind of rocky. They're not planets. They're asteroids. They're star-like. Asteroid.
Oh.
Star-like.
Star-like.
Because they're tiny dots of light, just the way stars are. Because they have nothing to do with stars. People presume there was a planet there. They found these fragments. And they're very excited about that. However, if you take all those fragments and glue them together into one object, you get something about 5% the size of the moon.
Well, that ain't a planet.
In our world, we have quantum physics where a lot of mysterious things happen. It's not mathematically mysterious. It's just intellectually mysterious. Particles pop in and out of existence.
Right.
Matter and energy are equivalent.
Particles behave in the same way over large
they're
periods.
entangled. You know,
Yeah.
there's weirdness that's going on. We can describe it mathematically, though. Is that weirdness completely normal in a higher dimension? Let's just ask for that. So what would be an example? Let's go back to our 2D world, okay? And we're there, we're walking around, slithering around, however 2D people get around.
We're line drawing.
Yeah, we are only our perimeters to each other.
Yeah.
Right. Suppose we're looking around and we see a dot.
Right.
It just came out of nowhere.
Yes.
It's like particles popping into existence. It's a dot. Where'd that come from? I don't know.
Right.
And then we keep watching. We study it. We're scientists. We study it. And the dot becomes a circle. And the circle grows. And we say, and we're studying it. We're making measurements. Then it grows to like a maximum point, and then it starts shrinking back. And it gets smaller and smaller. Then it's a dot. Then it disappears.
Wow.
We be coming up with all kinds of theories, right?
Aliens.
Do you know what I just described?
A hole.
No. I described a sphere
Passing through the paper.
The paper.
Because at one point, it's just a dot because it's a single point of the sphere that's touching the two-dimensional plane.
Exactly.
But as you continue to move the sphere through, then what you have is more points in a 360-degree sphere that keep fanning out, but only in 2 dimensions, so they make a hole that keeps getting bigger.
They make a
bigger,
circle.
A circle, and then...
And how big does the circle get?
Whatever the size of the diameter.
of
And
the
then
sphere.
you come back, and then you're down 1 point again.
And here we are mysteriously inventing forces and phenomenon, and it's just a normal...
Wow.
As you may have heard, the United States, NASA, has an accelerated plan to deliver a nuclear power plant to the moon. Plant actually overstates. It's a nuclear power device that can produce 100 kilowatts of power. So how much energy is that? You know how much energy a hairdryer draws. Typical hairdryer might draw 1,000 watts. If you delivered hairdryers to the moon, how many hairdryers could it sustain? 100 of them, 100,000 watts, because each hairdryer is 1,000 watts. So obviously that's not what NASA is planning. I just want to give you a sense of how much power that represents. It's not a major power plant. It is an energy source that would be sufficient to sustain a small colony. So NASA has pushed forward the timetable over which that would be delivered. Here's what's downstairs, living in a vat of water that is completely sealed. We have kelp, krill, and we have snails. And they have been living off each other for 25 years. Since January 1st, 2000, that's 25 years ago, they've been kicking it downstairs. They're symbiotically entangled. Now watch. When the construction was happening, the construction folks said, well, this looks pretty important and fragile. And they put a tarp over it. And so we caught it early, but, you know, there were a couple of belly up krill. Basically, they thought that this was its own thing. It kind of looks that way because it's a sealed sphere. It's not its own world. Right. It requires energy from the outside, just as we do here on Earth. I didn't know what the single most alarming thing I could ever see with the naked eye was until I saw it. This is 1999. I'm on the Brooklyn Bridge at 2 o'clock in the morning. And Brooklyn Bridge is you're away from lights. It's still very lit, but you're away from lights. And I'm there and I'm looking up and I'm seeing this meteor shower. It's called the Leonid meteor shower. You see the streaks of light. They're shooting stars. Yes. It's beautiful. We're getting like 3 or 4 per minute. This is a good rate. Then I saw a new star in the sky. I said, I don't recognize that star. And it just got brighter and brighter and brighter. And then it disappeared. Then I saw a puff of smoke. And I said, whoa. Do you know what just happened?
No.
It was a meteor that was headed straight towards me.
And it disintegrated.
And it disintegrated straight towards me. There was no streak. We are so accustomed to seeing streaks of light in the sky. And some of those are going to be headed straight for you. And they're not going to make a streak. They're just going to get brighter. When I realized a split second after that had happened, what I just witnessed, I freaked out. Earth is moving through space at 18 miles per second. And you have no knowledge of this. We had to measure this. We had to figure this out with telescopes, with smart people, with data, with calculations. We associate motion with, hey, I can feel I'm in motion. I can feel that. But the more pure motion becomes, the less you feel it. That's why on very large vessels, if they start moving, you don't even know they started moving because everything around you is moving. Your chair, your window, everything. If you're on a bus, sometimes it looks like the other bus went backwards. No, you started going forward.
Because you're surrounded by so many things that are also moving.
And everything is moving smoothly. If you're on bumpy road, you would know. Movement through space is smooth. Can't get smoother than that. It's not intuitive that Earth is moving anywhere. And this is why we went thousands of years with people thinking Earth was stationary in the center of the known universe.
What is making it move?
It's not what's making it move. It's that if it moved much slower, it would fall into the sun and we would all die. And if it moved much faster, we would escape from the solar system and we'd be a vagabond planet in interstellar space. So the only planets that survive the formation of the solar system are the ones that had the right speed at the right distance to sustain an orbit. And there's 8 of them. Get over it. The length of a second up until the 50s or 60s, I think it was early 1960s, was defined by a specific fraction of the duration of the year 1900. The year divides up into days, and then there's hours and minutes and seconds, and the rotating Earth is a key part of this measurement. Mm-hmm. Well, let me ask you, if Earth in a 24-hour day is your measure, then how do you measure whether Earth's rotation changes? You can't. If your measure of time is based on the rotation of the Earth and the time it takes Earth to go around the sun, if those things change, you will never know that because that is your yardstick. If your yardstick is changing, you will only know that if you have another yardstick to compare it to. We offloaded the measurement of the duration of a second to atomic vibrations, the cesium atom. There's a transition in the cesium atom where you can measure the vibrations of that in the laboratory. And the duration of a second was defined, and it has been defined that way for the past 60 years.
I was sitting at home and I wondered, why does the moon sometimes look so big? And I sent an email, and here you are.
Yeah, it's completely an optical illusion. In fact, it's called the moon on horizon illusion. And when the moon is rising, especially a full moon, and it's juxtaposed near mountains or trees or buildings, your depth cues are thrown off because you know how far away the mountains and buildings are, but the moon is essentially at infinity. And your brain trying to reconcile this makes it bigger than it actually is. It is not bigger. It is all in your head.
No.
And when the moon gets higher in the sky, you notice it's not as big as it looked when it was on the horizon. No longer is it juxtaposed near terrestrial things. Now, if, for example, you view the scene upside down, like you bend over it and look at it between your legs, then your brain can't recognize the buildings or the mountains and become small again in that instant. Go ahead and do that. We have 3 species on Earth. One of the most depressing things I learned, Saturn's ring system might just be temporary.
Why?
Well, because they track the orbits, and the orbits are not stable. You're losing them down into Saturn itself.
Do they anticipate when that might happen, that those rings disappear?
Well, so they suspected that it's a 10 million year or so lifespan, which would mean the dinosaurs, Saturn would not have rings for them.
Okay, I want to talk a lot about like the chicken or the egg debate.
People are still debating that?
They are.
It's not a debate.
That's what I think too.
No, it's not a debate. It's very clear and simple. The egg came first. It was just laid by a bird that was not a chicken. There is a bird that you perhaps would not call a chicken.
Yeah, proto-chicken.
Yeah, proto-chicken, sure. Yeah. And then there's a genetic alteration which occurs in every generation.
Right.
Very tiny genetic variations. And the egg that comes out of it, you would say, that's not a proto-chicken, that's a chicken. You go back, 300-400 years. If you fell on the ground, writhing and frothing at the mouth, and you're doing this and you're shaking, the devil just occupied your body.
Devil, boy.
That's what the devil looks like and feels like. So, oh my gosh, the devil's there. Let me go to get the priest. So you're in a small town. How far away is the church? It's 2 blocks away. Okay, so you go down, but I'm specifically referring to that condition when you're frothing at the mouth. Okay, so they get the priest. The priest gets the robe, the holy water, the crucifix. They go on location, they bless him, and then the symptoms go away.
Oh, now you're healed by the priest.
That is the exact
And it was a seizure.
And it was a seizure. It was an epileptic seizure.
Damn.
Epileptic seizure matches the time scale of you going to get a priest down the block in a small town.
Yeah.
Have you ever seen off-ramps to freeways? So off-ramps, have you noticed they have grooves in them?
Yes.
Okay. That's to prevent you from sliding off
Makes sense.
if the road is a little bit slippery because it just rained or whatever. They groove the off-ramp, a curved off-ramp.
Mm-hmm.
So you say, who invented those grooves? That's brilliant. It's simple and brilliant. NASA did. NASA. All right. Why? Because the space shuttle, which comes in for a landing, does not have engines. All right. It is a glider as it comes in for a landing, and it's got a parachute. And it's got some brakes, but it's really got, so if there's a crosswind, that's hard to fight that. So those grooves help it stay on track because it doesn't matter how you come in. The photo at the end shows how good a steerer you were. So some clever engineers decide if you groove it, then the shuttle can stay on course more tightly. And that was then borrowed for the freeway system.
So, ask Neil to disprove the flat earth theory.
A couple of things. During Ramadan, you fast during the day and you eat at sunset. Do you know in Burj Khalifa, the tallest building in the world, they issue a table, depending on what floor you're on, it's a different time that the sun sets. So if you had a higher floor, you have to eat a little later than those who live on a lower floor. And that can only happen if Earth is round. And not only that, and I did this back when we had a World Trade Center, so it was perfectly positioned facing Jersey. I have photos. And you can watch the sunset up the World Trade Center. It goes 1 floor per second. And so it's 107 flights up. So it would take about 2 minutes for the sun to fully set for those looking beyond the curvature of the Earth. It's also, we're in New York City. We've watched football games in the winter taking place in California where the sun was still up. Mercury's orbit is not following what it should. That's the closest planet to the sun. Well, we've been down that path before. Just throw in another planet that we can't see and that'll fix it. Thus was introduced planet Vulcan. This would be a planet very close to the sun. So close it would be hard to see, it would be lost in the glare. No one found it. Einstein comes up with his theory of motion and his theory of gravity, which are corrections to Newton's laws in these extreme regimes. If you're near the sun has very strong gravity. If you're moving around in that strong force of gravity, Newton's laws begin to fail. And you look at Einstein's laws, and he says, Mercury's orbit will not follow Newton's laws, it'll follow this other path. And it exactly explained the deviations of Mercury. And so people say, oh, see, scientists, we thought this was right, and now we all huddle around this thing that's right. No, the way it works is if you have an experimentally determined result, and it's verified, and double-checked and triple-checked, that will not later be shown to be false. What you can find is a deeper understanding that encloses that understanding.
What about the double slit experiment?
That experiment is widely misunderstood. This whole idea is the observer effect, where if you're not looking at it, you get one result, but if you look at it, you get another result, as though your consciousness is affecting the experiment. And consciousness right now is not a fully understood construct. So here's what's going on. We are illuminated by lights in this space. The light is coming from the bulb, reflecting off of you, entering my retina, going to my brain. Let's say you were smaller. Keep making you smaller and smaller and smaller and smaller. There is a size below which, when I turn on that light, you will absorb that light and jump to another state of existence. But if you're an electron, I turn on the lights, the photon hits the electron jumps to a different state. I cannot know what the electron is doing unless I illuminate it. And if I illuminate it, it's doing something different from what it was before I illuminated it. It has nothing to do with consciousness. It has to do with interacting with the object in order to make a measurement. Ben Franklin, he was the world's most famous scientist in his day. He's not remembered here as that. He's remembered as a founding father. He invents the lightning rod. What's happening before that? In any city, what's the tallest structure back then? The church is the tallest structure in any city. What is the most susceptible to a lightning strike? The tallest structure. So lightning would be taking out churches left and right. And if you were the other church that wasn't taken out, you had good argument for saying you're worshiping the wrong way. Ben Franklin then invents the lightning rod, which does two things. Dissipates charges that build up under your structure that would otherwise be part of the lightning strike, and it sends them back into the air without the benefit of lightning. So that makes you less susceptible to begin with. And if the lightning strikes, it then directs all of the charges through a metal and not through your house. So Ben Franklin does this, and churches are now no longer destroyed by lightning even if they are hit. And he's accused of heresy, thwarting the will of God. So that's why we have science. It's why the world is less superstitious than it once was.
And what's the one most important question you'd like to see answered?
I want to know what dark matter is. I want to know what dark energy is. And I want to know how you go from inanimate organic molecules to animate life. We can make organic molecules easily, like for free. Just put in some energy, shake and bake it. There they go. And Earth apparently had no trouble accomplishing this because it happened relatively fast in the history of the Earth. You go from molecules to reproducing life. And these are two great frontiers. Of course, I just spoke a biology frontier, but the astrophysicist is thinking, if you can do that on Earth, tell me how you did it, because it might happen on another planet. And that's this intersection of the astrophysicist and the biologist. The consumption of oil is not fully priced into the price of oil. So, for example, when roads were built, our tax money built roads. That enabled car companies to sell cars. If the price of gas contained the cost of making all the roads to drive the car on, it would be way higher than anything we ever paid for it. And then you'd see the true cost to you of using that technology, the internal combustion engine. So the actual price of things are kind of hidden within various sectors in society. I'll make a prediction so I can be made a fool of by people who come after me, that by 2050, 100% of the cars in the road will be self-driving electric. And you go say, oh, how can you say that? No, we're not on that pace. Look what happened then. What would you have said in 1900? When you see this newfangled automobile, if I told you in 10 years you won't find a horse, you'll say, no, I don't believe you. Things can't change that fast, but they did. Self-driving electric can go 90 miles an hour, one car length from the car in front of it. And it's not drunk, it's not putting on makeup, it's not texting. This past year, we lost 40,000 people to automobile accidents, pedestrians and drivers. 40,000 people. We just live with that. That's an entire Vietnam's worth of dead Americans every year. Society.
What's the most hilarious thing about the universe?
I think it's pretty morbidly funny what happens to you when you fall into a black hole. The gravity stretches you, so your feet fall towards the center of the black hole faster than your head does. And initially it kind of feels good, but then it's unrelenting and increasing, and eventually you end up snapping into two pieces, likely at the base of your spine. And like below your waist, you have important organs, but not vital organs. So you will survive that first bifurcation. And then those two pieces will split into 2, 4, 8, 16, 32. And all of these parts descend to the abyss. So what's funny about that? Not much, except that's not the worst of it. You also extruded through the fabric of space, because space funnels down to a point. And so you are stretched head to toe and squeezed, much the way toothpaste comes out through a tube. And there's a word for this. It's called spaghettification. Some guy 100 years ago, through brain injuries and other aspects of, because you can't just go in and start poking around in someone's brain. What he published was, the brain is so complex, we know only what 10% of it is used for. It got re-quoted as, we only use 10% of our brain. This is the mantra for teachers with students.
Right.
It's a very hard thing to correct when saying it incorrectly is what you want to hear. The Russians came up with the rocket equation. This is the equation that tells you how much fuel you need to put a payload into orbit. Why does that matter? Because you need fuel to carry the fuel that hasn't burned yet to put the payload in orbit. So for every pound you want to put into orbit, you need much, much more fuel than you'd otherwise think you'd need. And that's why the Saturn V rocket is so tall, and the astronauts and all their payload is just the upper little section. All the rest of that is just controlled bomb. A lot of people want to know what happens after they die. You put together all scientific evidence, biological and physics, and you have no existence after you die. You can believe what you want in a country where we have protection of religious expression, but if you want to ask science what science says about it, you go into a state of non-existence. You can say, well, why is that? What's that like? I'll tell you exactly what it's like. This is what it was like before you were born. You're not asking yourself, what was it like before I was born? I had to have some existence. You didn't. You have no existence, a state of non-existence before you were born. So I'm not given reason to think that your state of non-existence in death differs in any fundamental way from your state of non-existence before you're born, giving that much more meaning to what it is you can and should do while you're alive in this world.
Can anything or any object ever outrun a beam of light?
No. Not only experimentally have we never seen that. theoretically, we can declare that it's not possible.
And what's the significance of that?
It is one of the founding principles that make relativity real.
Right.
So we were discovering that this was true in our experiments. Einstein said, let's imagine that it must be so everywhere in the universe. What would then be the consequences? And out of this, he derives the laws of relativity. And then every time we test it, it comes out correct. He's just correct every time we test it. So he's got a very deep awareness and sensitivity of the operations of nature, just the way Isaac Newton did. That the first person to live forever is already alive. What enables that sentence to possibly be true is that get someone who's just born today. So we're working on the genome. We're isolating the aging gene, whatever that is. That newborn person, when they're 20, take this potion and they can now live to be 150. That would be a major advance on our longevity. By the time they're 40, we've improved the potion, now they can live to 300. By the time they're 60, now they can live to 500. By the time they're 80, now they can live to 1,000. By the time they're 100, they can live for 1,000,000 years. That's the notion, that we'll make incremental improvements that will continue to accrue for the person who's just born today. One of two things has to happen. Either we colonize other planets or you stop making babies. Because if you don't die and you keep making babies, that ups the population growth rate. So you need other planets. If you're not smart enough to have technology to get to other planets, living forever is not a good idea. Okay, one of my friends went up on the space shuttle to fix the Hubble. And on my Facebook page, I said, Godspeed the space shuttle. And someone writing, you said Godspeed. I thought you were an atheist. And was, why are you saying Godspeed? I said, well, have you ever used the word goodbye? Well, yeah, of course. That comes from God be with you. Why? Because you'd be leaving the city walls. That's dangerous. If you did that in a Christian world, you would say, God be with you, give you protection between cities. So Godspeed, the thing that will kill you in a rocket is speed. Okay, not a marauder or a mugger in space. And when John Glenn went into space, it was the headlines, Godspeed, John Glenn. And whoever criticized me for using that didn't know any of that. Most Pluto lovers I've met do not know the following three facts. 1, our moon has 5 times the mass of Pluto. 2, more than half of Pluto's volume is made of ice. So that if Pluto were where Earth is right now, heat from the sun would evaporate that ice and it would grow a tail, which is no kind of behavior for a planet. 3rd, Pluto has an orbit that is so elongated that it crosses the orbit of another planet. Excuse me, no. So we finally set up a set of rules and regulations such that Pluto is kicked out of the Planet Club. It's still a dwarf planet, but I think it's happier there. It's one of the biggest dwarf planets. Don't an egg
Jupiter is 90% hydrogen. Can we tell if it's a failed star?
Had it been maybe 5 times more massive, it would have been a star, and we would have had a double star system.
Why does that size suddenly make it a star?
Because the bigger you are, the higher the pressure is in your core. Because there's more mass, there's more weight, there's more pressure. And when you have pressure in the core, the temperature rises. And as the temperature rises, there's a threshold where you start fusing nuclei in the presence of heat. Thermonuclear fusion. The sun is undergoing thermonuclear fusion in its core. The high pressures, high temperatures are squeezing together hydrogen atoms, and out the other side comes helium atoms. And the helium atom has less mass than the hydrogen atom. Where did the mass go? E equals mc squared. It became energy. And that energy is sustaining the star. Humans are one of the few mammals, maybe one of the few animals at all, that's comfortable just sleeping on our back. You've never seen a horse asleep on its back. Most mammals just do not sleep on their back. And we sleep at night. I'm asleep on my back at night, and then I wake up. I look it up. I look at the star. Because the moon was here last night, but now it's there tonight. And there's other brighter ones, the planets, and they moved. You gotta be curious. You have to be. And I bet this imbued our species with a sense of curiosity for what is above our head that a beetle could never have, because a beetle's only looking down.
There can be no time travel because so far, no one from the future has ever shown up and said, hi.
That requires there's no time travel to the past, because the future person would then be coming to the past. We can travel into the future, however. Our understanding of that has been around since 1905, and it's Einstein's special theory of relativity. If I send you on a spaceship at speeds nearing the speed of light, and we watch you, we will see that your clock ticks more slowly than our own. and then you come back. It's the famous twin study. You send out your twin, they can come back. You aged 20 years, your twin would have aged only 10, depending on the exact speed. And so in that way, your twin went into the future. Now, you're right about the past. We don't know yet how to go into the past. There's some peculiar solutions of Einstein's equations that allow past travel, but then you can't interact with your life. Because imagine if you could interact with your own life, prevent your parents from meeting. Then you were never conceived. Then you could have never been sent back in time to prevent your parents from meeting. Right. I read a statistic. I believe it, but I haven't confirmed the numbers on it. Some number like 70% of all men in the United States have jobs that involve driving. So you add it up. There's like truck drivers, cab drivers, forklift drivers, delivery car drivers, FedEx, UPS. This just keeps adding up. And if you're ever driving on a busy freeway, trucks are all over the place. Somebody's driving that truck. And so the day all driving becomes self-driving trucks and cars, all of those folks are out of work. I fear that most people don't know that the sun doesn't set on the same spot on the horizon. If asked, people say, well, the sun rises in the east and sets in the west. But it doesn't. It only rises due east and sets due west on the equinoxes, March 21st and September 21st. All the other days of the year, it is rising and setting somewhere else on the horizon. Now we look at Manhattan, which has a street grid. Generally, we think of uptown as north and downtown as south. However, the grid itself is not oriented exactly north-south. It's rotated about 30 degrees from due north. Combine all these facts, you can ask the question, is there a day of the year where the sun sets exactly along the cross streets of Manhattan? Well, you get this alignment 2 days a year. And for New York City, in our grid, 30 degrees rotated, and all the orientation, it's May 28th and July 11th. So I just thought of calling it Manhattan Henge. What's up? I grew up in New York City. Every night, the evening news would lead off with a fire in some home.
Usually it's a space heater, those little space heaters.
No, back then people smoked in bed.
Oh.
Okay,
Damn,
Smoke,
boy.
and it was before.
That's crazy.
And it was before.
It's fun to do, but
smoke alarms.
Yeah.
Okay.
Ooh.
The point is, I was certain I would die in a fire.
Damn.
I would never live to adulthood because I saw that every single day. And so now there are fewer fires because we have smoke. Yeah, there's a few and they make big news, but the rate compared back then, New York has fewer firehouses. We've been closing firehouses.
Well,
you
boring.
just don't need them. And by the way, what really saved things are smoke detectors, because before smoke detectors, you had to buy flame retardant things in your home. Your curtains were flame retardant. Your child had flame retardant onesies.
Yeah, really?
Okay. But if you think that through, if they're in the crib and the flame is strong enough,
it's not going to help.
My point is, this flame, and we later learned some of them cause cancer. That's not what kept people alive. Ultimately, it's the smoke detector delivered.
Wow.
Here's what's interesting about NASA. Realize NASA is 10 centers across the United States. 10 centers located in 8 states. And variously, those 8 states will vote 4 red, 4 blue, 3 red, 5 blue, 3 blue, 5 red. And so that's interesting, which means NASA is embedded into the political spectrum of America. What that means is the vision statements of NASA as an expression of what the country wants to do actually transcends presidents, and on some level, therefore, transcends politics.
Well, partly it's taken to these very strange images that are behind your head right now. These are pictures of equations. I've been, for the last 15 years, trying to answer the kinds of questions that my colleagues here have been raising. And what I've come to understand is that there are these incredible pictures that contain all the information of a set of equations that are related to string theory. And it's even more bizarre than that, because when you then try to understand these pictures, you find out that buried in them are computer codes just like the type that you find in a browser when you go surf the web. And so I'm left with the puzzle of trying to figure out whether I live in the matrix or not.
Right. You're blowing my mind at this moment. So you're saying, are you saying your attempt to understand the fundamental operations of nature leads you to a set of equations that are indistinguishable from the equations that drive search engines and browsers on our computers?
That is correct. So
wait, I have to just be silent for a minute here. So you're saying as you dig deeper, you find computer code writ in the fabric of the cosmos?
Into the equations that we want to use to describe the cosmos. Yes.
Computer code.
Computer code, strings of bits of ones and zeros.
It's not just sort of resembles computer code. You're saying it is computer code.
It's not even just is computer code. It's a special kind of computer code that was invented by a scientist named Claude Shannon in the 1940s. That's what we find very, very deeply inside the equations that occur in string theory and in general in systems that we say are supersymmetric.
Okay. Time to go home, I think. I'm not sure. Where are we going to go? So are you saying we're all just, there's some entity that programmed the universe and we're just expressions of their code?
Well, I didn't say that. Some of those,
like the Matrix? That's what you said.
Some of those codes are showing on the screen behind you right now. They don't look like codes, but these pictures, which we call deGrasse, are graphical representations of sets of equations that are based on codes. So this is, in fact, to answer your question more directly, I have in my life come to a very strange place because I never expected that the movie The Matrix might be an accurate representation of the place in which I live.
Jim,
What is the Andromeda paradox?
Well, the Andromeda paradox is the fact that if you and I are looking at Andromeda 2.5 million light years away, then what happens is, suppose you're sitting in your chair and I'm running by. And at the second I run by you, we both look up at Andromeda. Because I'm moving and you're stationary, we're going to see events that are days apart, even though we're in the same location looking at the same time.
How can that
and
be?
you think that relativity, and you think that the
Don't just
light
say
arriving-
relativity and keep talking.
How
I know,
far?
right?
Wait, in this scenario, how far away from me are you when you're running by?
You're in the same
me?
place.
We're in the same place, essentially.
So
I've
you're
never-
like literally
I've
running
never
here.
heard of this paradox.
And you look
right,
up,
it's a little known paradox.
and the
right?
thing
Yeah.
that you see and I see are days apart
Days apart.
because of our physical perspective. On
Well,
that?
here's what you would think. You would think the light is arriving right now. We should all be receiving this light, but that's not how it works. Motion changes the perception of time. So how do you define what now is? So we
Even
don't
though you're in the
understand
same
time.
place.
Even though you're in the same place. Yeah.
While we're sitting here, I'm here, you're running by,
Yeah.
we look up at Andromeda at the same time,
Yep,
and we're
from the
seeing
same
something
location.
From the same
days
location.
from the
Yeah.
same location,
Yep.
essentially. We're seeing things days apart.
Days apart.
And
Yeah.
that leads to the idea of what is now, and your now and my now are two different
There's no
nows.
now.
There is no now.
No, there is now. There's always now.
There's an
There has
illusion
to
of
be.
now because we're so close together and we're so small. The speed of light makes it feel like we have a now, right? But now doesn't really exist on larger scales. There's no such thing.
Continental drift. This is a fascinating bit of history here. There's someone who looked at the shape of South America and the shape of Africa on a map.
Yeah.
And said, wait, that looks like it fits. But there's a whole ocean between them. But it kind of, is there a puzzle? Did these land masses once connect? Let's test this. Well, what might you do? You say, if they once connected, might there be fossils in common on both shores, even though there's an ocean between them? So you look, the fossils match. Oh my gosh. And other things start matching, but wait a minute. How the hell is land gonna move on a solid surface? No one had any idea about this. No understanding. That notion that a continent would move when no one had a mechanism to make it happen, it just sort of stayed there on the shelf. The consensus was not ready to go there.
Right.
And so what happens after the Second World War? Well, we're mapping the bottom of the Atlantic, so the subs know where to hide and where to go,
Yep.
the submarines. And in the center of the Atlantic, there's a ridge. Oh my gosh, there's a split. It's separating in the middle of the Atlantic. Once that was uncovered and revealed, declassified and published, boom, we had the mechanism and all the data fit. A couple of years ago, I interviewed one of the founders of Twitter. And I didn't know at that time. He's not a household name. People, Twitter fans might know him. Biz Stone was his name. But one of the things he said is Twitter enables humans to flock. And I said, what? What do you mean? Well, birds are individual while they're pecking away. Then something happens and then they all do this.
Yeah.
And then when they figure out they're done, then they come back and they're individuals again. Twitter can garner people's behavior, thoughts into one coherent action. And then you release it and you're back being your individual self.
Wow.
I foresee the day where AI becomes so good at making a deep fake that the people who believed fake news as true will no longer think their fake news is true. Because they'll think their fake news was faked by AI. The day that happens, the entire role of the internet as a source of objectively true information will implode. And that will be the death of the internet as that source. Like 1992 to 2028, whatever. Rest in peace. And the internet will return to just cat videos and other. Remember when we just would entertain each other with videos? The internet will return because AI will be so good at faking news. Here, I got another one. Consider that Muslims, part of the rituals of being a Muslim is you're cleaning your hands and your feet and your ears and your nose. And there's a cleansing daily. But just think about this. Back then, nobody's showering every day. But some funky times, okay? There's some people don't shower every day today, but you could. And United States, we probably take more showers than anybody else in the world from the research I've done on that. But point is, if a disease comes through and it comes from contact, or some other thing because you're dirty, you get sick and the Muslims don't.
Oh, so they seem powerful.
Oh my gosh. And you're Christian and they're Muslims? You're saying they put a hex on me. These heathens. Okay?
Wow.
This is how this can happen. I got another one. You ready? So we would later learn that many of the plagues were from a flea. Okay? So now watch. So the flea would get infected and would bite you and you'd get the plague. Okay?
Okay.
The plagues have killed more people than practically more than wars. Okay?
Oh, wow.
All right. So now watch what happens. Where did the fleas come from? We would later learn they came from rats and mice. Okay? That were infected with the plague. If you owned a cat, you didn't have mice.
So you didn't get the plague.
You didn't get the plague. No, wait a minute. Who owned cats? Well, there are many women that own cats.
So women didn't get the plague and they were therefore sorcerers.
They were witches.
Damn.
And you still associate a cat with a witch.
Yeah.
To this day. This is what happens when you live in a pre-scientific era.
Wow.
The blame game begins. The embarrassing inability for the human mind to embrace probability and statistics. It's on a level where, let me back up further. Do you know major branches of mathematics? We start with like arithmetic and then algebra, then trigonometry, even calculus.
Right.
Do you realize that our full understanding of probability and statistics as a branch of math did not occur until after those other branches of math were developed? And you might say, why? What's a simple statistics you can take? You can just take an average of numbers. You realize the first time someone took an average of numbers and said this could be helpful was after all of those entire branches of math were established. It is not a native way for the human mind to observe and think about the world. Your intuition, you want to rely on rather than a pure statistic. And that gets us into trouble because our feelings matter so much to us. And in the face of raw statistical data, it's so easy to say, I'm going to go with my feeling because I trust my feelings on this. It's why TV commercials, if I happen to have a good product and I have good evidence that it's a good product, I can just show you a bar chart or something and say, here, we are on the top end of this. Go buy it. But no.
That won't work.
That doesn't work. So they bring people on who have experienced the product. This is the best thing I've ever had. And you're listening to another human being, another member of your own species, communicate to you the value of that product to them. And we respond so much more to that than to pure statistics that it leaves us vulnerable. My professional community of physicists, the American Physical Society, hold annual meetings, and one of them was to be held in San Francisco. This is 20-some years ago. Sorry, it was going to be held in San Diego, and there was a hotel snafu, and so they had to reschedule. And what are you going to do with 2,000 physicists? And so the MGM Marina in Vegas said, we'll take you. So everybody shifted there. Thousands of physicists descended on Vegas in this hotel. A week later, the headline was, physicists in town, lowest casino take ever. Did we just know the odds better? No one bet. There is an entire industry within us in society that has arisen to exploit your inability to think statistically, and it's called casinos. The prevalence of life in the galaxy, if you can quantify that somehow, I don't know how to quantify it just yet, but imagine that's a quantifiable entity. The prevalence of life that we presumed to be out there. The stock in the prevalence of life has gone up in the past 10 or 15 years.
Why?
Because, for me, the best argument for upping that stock value is the following. I don't know the age of everyone in the audience, but I would bet that when you took biology class and you learned the age of the Earth 4.5 billion years ago, and then you look at the earliest evidence for life, fossil evidence of life on Earth, then you get about 3.5 billion years. Subtract those two numbers, get the difference between those two numbers, and that's the time clock from beginning to the first evidence for life, okay? That was about 1 billion years out of the 4.5 billion years that Earth has been here. So that's pretty quick. It happened in like the first 20% of the life of the planet.
And the first 20% was pretty rough. There was a...
Wait, no, hold on. Since the time we all took biology, we have found fossil evidence of life farther back in time than 3.5 billion years. It now goes back to 3.8. There's some evidence it might even reach 3.9. So we have shrunken the time available for life to have formed on this Earth. That makes it more likely. If the faster life kicks in from a pool of just random chemicals, not random, they're the chemicals of the universe, the faster that happens, the more confidence I have that life is something that would happen just given the right soup and soup starter. Okay? Now, we then learned when computers got good, better than they once were when we were in school as kids, the early solar system didn't just simply make the sun and the planets. There was debris all scattered in interplanetary space. And that debris slowly got vacuumed up by the gravity of the respective planets. That would not have been a pleasant occasion on the surface of those planets, because to vacuum it up simply means you're getting slammed by the kind of asteroid that took out the dinosaurs, except you're getting that monthly. And you can calculate what the temperature of Earth's surface would have been. And it would have been higher than what would allow complex molecules to form, because at high temperatures, you break apart molecules. So what our computer models show is that this period of heavy bombardment is the official phrasing, lasted 600 million years. So it's not fair to start the life clock at 4.5 billion years ago, because life had no chance of forming when the surface of the Earth is molten. Wait for things to cool down. When there's a chance that carbon can run its magic, then you start the clock. Now you're going from 4 billion years ago into 3.8 billion years. And you have pinched the time it takes to start life down to 200 million years, down from 1 billion years that was imagined just a generation ago. And that is further evidence. Practically the earliest life could have formed, it did. So just because we find it hard to do in the laboratory doesn't mean nature had found it hard to do as well. And the idea that it's hard for nature to do because we can't figure out how to do it yet, that itself is an inexcusable expression of human ego.
All right, let me finish the thought.
You know what an egg is?
A cell.
No, I was going to be more metaphorical.
Oh, what's an egg? What's an egg?
This is not a biology class here.
I'm sorry.
Okay, you know what an egg? An egg is a spacesuit for the unborn organism so it can survive in an environment that would otherwise kill it.
Yeah, it is.
Until it can survive, then it no longer needs the spacesuit.
That's true.
Think about that.
I've never thought about it that way.
Yeah.
That's cool.
Right? So the chicken is inside the egg because the outer environment can't live in that environment. So it stays in there until it's ready. Then it pops out and it can
leave the ship.
Leave the ship. But I was born after the discovery that the heavy elements that populate the universe, and including life on Earth, including us, derive from stars that manufactured them in the crucibles that are their cores, and then exploded, scatter that enrichment across the galaxy to enable nascent star systems to have the right ingredients to make planets, and on some planets make,
I don't know, people.
Yeah, people. Then, in the 1990s, we discovered icy bodies in the outer solar system that rivaled Pluto in size. And then we found many of them. And so what we concluded was Pluto wasn't so much the 9th planet. It was one of the largest of the icy bodies of a new swath of real estate that we added to our understanding of the solar system called the Kuiper Belt of comets. So we still had the basic solar system. Pluto was always a bit controversial, but we've now grown in our larger understanding. Yes.
Okay,
So what they decided to do is for people who are about to die, they would write a message facing upwards to the ceiling above the bed and suspend it there. So if a person goes above their bed and looks down, they'd be able to read the message. So when they rejoin their body, they should then tell us what message they saw. That's never happened. It's just. Now, I have a cousin who, when her father died, was alone with him in the room, and he's in an open casket. And she's otherwise completely rational, okay? I'm not saying this is a crazy person. She's a real estate agent. She tells me of a conversation she had with her dead father. And I said, was it in your mind? No, he sat up and spoke to her. I said, what was the conversation? And she said, well, he said, don't worry about him. He's in a better place, this sort of thing. So This is her eyewitness testimony. I'm not going to say it's wrong. I'm just saying it's not scientifically useful. I told her, next time this happens, ask these questions and not those questions. Okay? Don't say, are you happy? No, saying, are you wearing clothes? Where are you? Where did you get your clothes? What temperature is it? Just ask questions. Like, this is an amazing scientific experiment you could be performing. That's my lesson to all of you. That if you find yourself in that situation, okay? Because if a dead person sits up and starts talking to me, oh my God. Do you remember there was this double rainbow guy? Have you ever seen this?
No.
Okay, this is now back when social media was just people posting things. It wasn't the cesspool that it is today.
Yeah.
So he was hiking somewhere. There's some guy back when you needed a camcorder to take videos, not a cell phone. He's hiking in, was Sierra Madres, I don't remember where. And you hear him sort of narrating. Then he turns a corner and he says, oh, a rainbow. Oh my gosh, what could it mean? Oh, a double rainbow. Oh my gosh. You don't see him, but you can easily interpret just his emotions and his breath. And he can't contain himself. What does it mean? This is a sign. So I felt bad doing this. You might be proud of me, but I felt bad doing this. I tweeted, I put a link to this video and I said, this is how you behave if you've never studied physics.
Yes. Is the north and south sides of a magnet actually different in any way outside of the attraction and repelling effects? How would you determine which side of a magnet is which?
Okay.
So you don't have anything to go on because you can't turn them and attract or turn them and repel. You have to determine which one is north and which one is south.
It is completely arbitrary. What I mean by arbitrary, it's that we all decide what to agree on, and then that's the answer. It's not a fundamental thing in the universe that tells, this is north. That's
right. I got you.
Now, think this. Remember, like poles will do what?
They repel.
Repel, and opposite poles attract.
Okay.
By definition, if you have, let's say, a bar magnet, because it'll work better.
It's easier.
And you hold it with a string in the middle, and it'll turn. The part that points north on Earth is the north pole of the magnet.
And that's it.
What that means is, if the north pole of your magnet is pointing to the north pole of the Earth, where is the Earth's south magnetic pole?
Wait a minute. The north pole of the magnet is pointed towards the north pole of the Earth.
What attracted it?
The south magnetic.
Yes!
Oh, snap! Go! No, come back, Chuck. I need you. That's insane. The north pole is the south pole.
Yes.
On Earth. God. That is effing ridiculous.
You know why airplanes have pointy noses that go faster than sound? Because you need to, because the air does not part for you. You have to cleave the air because you're moving faster through the air than the air can tell other air molecules that you're doing that. Because the air molecules communicate with each other at the speed of sound. If you're moving through it faster than the speed of sound, you have to cleave the air to make that happen. And so all your front surfaces have to be pointy. Oh, the Top Gun movie, I tweeted about that. Tom Gunn ejects at Mach 10.5 and just walks back to base with a slightly dirty face. He would have been squashed by the shockwaves at Mach 10.5 the way a bug hits a windshield. Wow. Yeah, he wouldn't have survived a fraction of a second. If he ejects, he is in no such shape or vehicle, and he basically is blown apart by he's going 7,000 miles an hour.
Will we ever be able to teleport? Is this going to ever be possible?
Teleport. So take your body, turn it into energy, beam it over here, and reassemble it.
Yes.
I think a wormhole between those 2 points will come sooner than teleporting.
In our lifetime?
And a wormhole is just great. You just step through. You don't have to dematerialize and rematerialize. A wormhole is you're over here and you want to get here during the TV commercial. You bend space, you cut a hole through there, pop out, and there you are, and you got to cross the galaxy in seconds. I was tweeted. I was in like Charlotte Airport or somewhere where I had to go from a big plane to a little plane. It was like miles through the airport. And I tweeted, I tried to be clever. I said, gee, I can't wait till we have wormholes so that all gates will be adjacent to one another. And then someone tweeted back, said, Dr. Tyson, the day we have wormholes, you won't need airports. Yeah. Cancel culture. There are more water molecules in this cup of water than there are cups of water in all the world's ocean. That's how small molecules are. So what that means is if I take this and toss it out, there's enough molecules in what I toss to enter every other possible cup of water anyone draws from the world's water supply. There's enough to scatter to every possible cup of water in the world. So if I drink this, it comes back out of my body in some way or another, any one of a half dozen ways. That re-enters the environment, goes to clouds, it goes to the streams, goes to the oceans, and given enough time, it mixes completely. So Socrates drank a glass of water. It is a certainty. It's essentially a certainty that some molecules that passed through his kidney were in that glass that you just drank. And it's not only that, by the same reasoning, there are more molecules of air in every breath you draw than there are breaths of air in all the Earth's atmosphere. So by the same calculation, every breath you take, some of those molecules pass through the lungs of whatever is your favorite historical character, Jesus. You want to think of us as separate and distinct from one another or not connected to the world, but we are. And for me, what I think of as fascinating ways.
Was Galileo treated as a kind of a devil, in a sense?
The simple story is he makes these discoveries. They conflict with the teachings of the Catholic Church. They put him on trial. They find him guilty of saying that Earth goes around the sun and not vice versa. And then they put him under house arrest. What they don't tell you, or they would tell you if you read a longer biography about him, is that he actually made fun of the Pope, public fun of the Pope. He wrote a book in Italian, not in Latin, which is the academic language of the day, in Italian, which means the local people can read it. And in it, he invents a conversation between a simpleton and someone who was wise of the ways of the universe. And all, if you track the statements of the simpleton, they're all statements that have come by official decree from the Catholic Church. So he's really a pompous a-hole, basically.
When going to a different planet, what aspect of traveling will be most important?
Great question. And there's a lot of thinking about this. They worry about food. Not only is there enough food, but will you like the food? If you get bored with the food, will that affect your morale? And then you're less effective doing other tasks. Do you need comfort food? Do you want exotic food, international food? The water supply. Is there enough water? Do you recycle the water? If you recycle the water, that means it collects all of your urine, filters it, and then you drink it back. Is that too freaky for you to do? Other things, the time in a close quarter with only one or two or three other people, months and months, and in some cases years. Can we remain emotionally stable over those times? There's the fact that if you fly without creating artificial gravity, that you are weightless the whole time. Are you perpetually motion sick? Or do you get used to it? And if you get used to it, are there any other factors on the body? We already know some of the answers to that. You begin to lose bone density. You have the bones of a frail old woman. All of these factors have to come together, which is why you can't just send any old person into space. Cancel culture is, this is one thing you did, I don't like anything you did. Yeah. And when did that happen? There's one thing about you I don't like, therefore I don't like everything else about you. We're not talking about a case that doesn't exist, such as, suppose Hitler actually invented a cure for cancer. What do? Do you use the cure for cancer? Is there a statue to him?
Hitler did invent some stuff. I think the Volkswagen.
Yeah, the Volkswagen. Volkswagen. And in fact, it's the air-cooled variant in the range of Volkswagens was so that he could conduct his military operations in Africa where there's no water.
How do you sum up to someone who says that the Earth is actually round? How can you quickly prove that?
Here's a good one. You ready? We're here now in the East Coast, the Eastern time zone, especially in the winter. You're watching Sunday football. The sun sets in New York at 4:30. A football game in LA at that same time, it's daytime. The sun is up. At 1:30 in the afternoon, the sun is high in the sky. And you know that's happening now. The game is live. So how is it that the sun is set for us and then you go west and the sun is not yet set for them? Can you explain that? And I've yet to hear any of them explain that.
Is it actually hypothetically, scientifically possible to terraform Mars and create oxygen on Mars where you can step off your spaceship and go hang out in Mars?
I see no law of physics that prevents it. But what I will say is we are still running away from hurricanes. Buy toilet paper, buy water, run. When the volcano erupts, we lose our cities. There's stuff happening on Earth that we do not control. We are victims of Earth being Earth. Now you want to completely control what's going on another planet? That's a level of geoengineering we do not yet have on Earth. If you have the power of geoengineering to terraform another planet, then you have the power of geoengineering to terraform Earth back into Earth. So the whole premise of that film, Interstellar, where there's a blight on the crops, everyone is starving, let's go find another planet and ship 1 billion people there. Whatever effort that takes, it seems to me, you should be able to fix the genome of your corn crop. Right. Really? The number of people who could exist in the combinations of the human genome vastly exceeds the number of people who have ever been born or likely will ever be born. In other words, most people who could ever exist will never exist. So we are alive against, as individuals, against stupendous odds. We won the lottery. We will die for having had the privilege of living, because most people who could exist will never even be born.
In regards to enemies America may have, what keeps you up at night?
Those aren't the kind of thoughts I have. You look around the world, there are always warring factions, but I try to put it on a scale. And on that scale, today, there's conflict in the world, and sometimes if it's armed conflict, people die, this sort of thing, of course, in Ukraine and Russia and this sort of thing. When I look back to the Second World War, between 1939 and 1945, 1,000 people were killed per hour of every hour between 1939 and 1945. You want to talk about a time of violence? There is no comparison to that period. We look back on it, we won the war and we had the technology, and it's remembered differently from the carnage that caused. And so when I look around and I see carnage in the world and I index it to that, I say to myself, we're in a relatively safe world. And you have a time machine. And someone says, and I talk about this in the book, they say, here's a time machine. You can have access to any time in the history of civilization. Where would you go? And choose a time where you'll be better off than you are today. There is no time.
You're going nowhere.
You're going nowhere. Send me to the future. Because the arc of progress, the arc of morality bends towards progress. And nowhere at all